Hello and welcome to this presentation about factors affecting quality of data and information. The intended audience for this presentation is VCE Computing students in Units 1 and 2, and this is how it appears on the study design there, but it would also fall under the category of data integrity for Units 3 and 4 software development. Let's have a look at our first slide. So that's our learning intention, that students can identify and explain all 5 factors in assessing the quality of data and information. And one of the factors has sub-factors. I'm not saying the sub-factors are going to turn up on the exam, but I'm going to talk to you about them anyway. And who knows, they might. So number 1 is accuracy, then bias, then integrity. So part of data integrity is this dimension called integrity, relevance and reliability. So let's go through these one by one. What do we mean by accuracy? Well, this is probably the most self-evident of the 5. We mean that what it measures is closest to the true or correct value. Now, this is actually interesting, particularly when it comes to floating point values, because the way that a floating point value gets stored is really interesting in terms of the way that the bits operate. And so they're actually approximate values in lots of situations with computers. And so that doesn't mostly matter most of the time, but computers are not, we talk about them being binary, which means there's ones and there's zeros, but we are rounding information. There is error that creeps into data collection. So accuracy is one of the things we're going for. How close is it to being specifically true? It's critical in scientific, statistical and professional contexts, and it involves minimizing errors and discrepancies. So, and it's essential for decision making and credible reporting if our information is inaccurate. And sometimes it's not just inaccurate by a tiny fraction of a percent, sometimes it's really wildly inaccurate. So we need to be aware of this. One of the things that you can do is you can cross-reference it. You can say, well, here's the data and here's credible data. Are these things a good match? Is this a reasonable result here? Statistical validation, does the shape of this data, we talk about a normal distribution, which is what we mean when there's a few scores at the bottom and then most in the middle and then fewer scores at the top. Not everything holds to that model, but you can do statistical validation and say, hey, is this data lining up with what we would expect to be true? Just repeated testing, is a good way to get accuracy, because if you repeatedly measure something, you're much more likely to have confidence in that as an accurate result. Calibration of measurement tools, and we're going to talk about measurement when we come to bias as well. Now, bias. Bias is one of these wonderful terms that gets thrown around, and sometimes in a very broad sense. Oh, that person's biased, and it's thrown around as an accusation without much thought for what it actually means. And I think we all like to think of ourselves as unbiased. All bias means is there's something in the way that we're collecting it that means that it's distorted from the way that the real world is. Think of it when you put a stick in water, how it looks like it's bending. Well, it's not that anybody's lying or being disingenuous, it's just that the situation is being misrepresented to us just by the nature of physics and the way that the light is bending. So the first one I want to talk to you about is selection bias. If you were to ask these cheerleaders, who is the BEST team, they're going to pick the home team. Now, that's a really egregious example of selection bias, but, if you were to ask teachers whether they think they should get to cut into the canteen line, well, there's a degree of selection bias there. Likewise, if you ask only students, or even if you ask both, just any population can have a selection bias in it. Asking your existing customers, why they think people don't buy your product. These are people who've already bought your product. It can actually be really hard to filter out selection bias because you've got to work with the people who will work with you. Confirmation bias is where you tend to see what you expect to see. I'm reminded of the hit film Jurassic Park. Now, I know this was a long time ago, but either in the book or the movie, they had this really memorable scene where the sensors were tracking how many of each type of dinosaur there were. and they expected that the dinosaurs couldn't breed. So they actually had validation in that number so that it couldn't go higher than the number that they knew that they had. And when they turned that assumption off, it turns out that the monsters, shouldn't call them monsters, the dinosaurs had been breeding, but that confirmation bias that they were looking for what they already believed to be true. And it's very easy to look at that and say, oh, well, I wouldn't do that. We do this all of the time. You know, when I hear a Billy Joel song, I'm expecting it to be bad, so I listen for things that are bad about it. Biases of all sorts are much less about people being malicious or ill-willed, and more about the fact that collecting information about the world in a genuinely unfiltered way is difficult. Sampling bias. Sampling bias is somewhat similar to selection bias. So we are choosing the data that represents what it is that we want to hear. So we're looking and going, oh, look at all those smiling faces. These people love who we are. Why they have the face paint, I could not tell you. But the sampling bias, the sample that we're taking is misrepresenting the world as it is. You know, an example for this would be if I were to be running my robot, and a common task I do is called Curve Runner, but I'm only measuring the successful runs. Well, that's true, but I'm getting a measure of how quick the successful runs are, but I'm actually leaving out a lot of data that would also represent the truth of the situation. So sampling bias, very real thing. Reporting bias is actually somewhat similar in that if I'm only reporting some of what happens, an example for this is, so I've got an app, and the app, you know, when you meditate on it, you feel happier. And what I'm doing is I'm just reporting on the people who've said that they get happier. I've decided that the people it doesn't work for probably weren't doing it properly, or, you know, this, that, and the other thing. In this example, she's thinking, oh, these projects are fantastic, but she's not looking at the ones that's on fire in the background. There seems to be a bit of smoke behind that rocket. I couldn't tell you why. But reporting bias is absolutely a thing. And then we just have measurement bias. Sometimes the instruments that we use are not giving us an accurate measure. Now, that might seem really odd to you. You'd think, well, the temperature is the temperature and the distance is the distance. But that isn't necessarily so. You can have instrument bias. You can have observer bias, where people can just misunderstand things because of where they're seeing it from. You can have things that are incorrectly calibrated. You can have a thing called a scale bias. Now, the scale bias isn't that your scale is biased, it's to do with the way that you scale the data up and it misrepresents what's going on with it. You've got environmental interference. You know, if I'm trying to use a sound sensor and it's a really noisy room, then I've got environmental interference as a source of bias in that sound sensor. It's going to appear much less sensitive than it really is. And you've also got systematic measurement drift. And systematic measurement drift is just where things go out and we don't necessarily notice because it's happening very gradually, and we don't realise that the thing that was measuring accurately yesterday, 6 months ago, 12 months ago, is no longer measuring accurately. And then we have cultural bias. I think that lots of people, and myself included, fall into the trap of thinking, well, I can think of other cultures that have got blinkers on, but luckily I see the world as it is. So this image is of doing a survey about coffee in Melbourne. Now, Melbourne people are famously snobby about coffee. You know, I walk past Starbucks. I'm actually not a particularly big coffee person. I do drink it, but you know, we have a culture of taking ourselves terribly seriously when it comes to drinking real coffee and good coffee and so forth. And so if you were to ask people, you know, is this McDonald's coffee a good coffee, or is this Starbucks coffee a good coffee, you'd actually get a cultural bias in it. So I think sometimes we throw that around as a very pejorative term. So, oh, this culture does this and this culture doesn't understand this. We all have cultural biases. No matter what group we belong to, we bring biases with us. And so that's something that you've got to account for too. So let's see what we know about biases. So a researcher studying smartphone usage surveys only people walking through an Apple store. Now, I've actually got the answers over here, so I'm just going to have a quick look at them. So that, I'll say it would help if it was on the right screen for me. That, I would say, is either a confirmation bias or a sampling bias. A teacher believes boys are better at maths, so she only notices and remembers when boys answer difficult questions. That's a confirmation bias. She's seeing what she believes she's going to see. And a fitness app study only published results from users who lost weight, ignoring data from users who gained weight or saw no change. That's a reporting bias. A survey about internet speed only includes responses from people who completed an online questionnaire, excluding those with poor connections who couldn't load the page. Well, that's a selection bias because the people you're choosing aren't representative of the whole population. A bathroom scale consistently shows weights as 2 kilograms lighter than actual weight due to incorrect calibration. Well, that's a measurement bias, and in particular a calibration bias, and I have to say that's a set of scales I would like to have. An AI facial recognition system trained primarily on European faces performs poorly when identifying people of Asian or African descent. Well, that's a cultural bias. It's trained on a particular data set from a particular culture, and so it works best for that. An interesting real-world connection for that is IQ tests, which were conducted on European males. And there are questions about how well it captures intelligence from other people. A journalist writing about electric vehicles only interviews people at a Tesla enthusiasts convention. Well, I would say that's either a sampling bias, because you're picking a narrow, non-representative sample, but it might also be confirmation bias, because these are people who already think that this is good, and you're asking them whether it's good. A scientist researching a new drug dismisses unexpected side effects as outliers because they contradict her hypothesis. I would say that's either a reporting bias or a confirmation bias. And a voice assistant struggles to understand commands spoken with a strong Indian or Scottish accents because it was trained mainly on American English. Well, that's a cultural bias. It doesn't just have to be about what we hold in our head. It can be about just different cultures and the way they express themselves. So, the next dimension about a factor that affects data quality is integrity. And as I said earlier, data integrity is a kind of catch-all term that we can use for this as well. In this context, we mean that information remains accurate, consistent and reliable throughout its entire life cycle. Now, the life cycle is the key concept here, which means we can maintain its trustworthiness and usability. So, what we're really asking when we ask about integrity in this sense is, was it created by an authorised person, and has it only been edited or updated by authorised people? It's about the provenance of the data. Can we trust we know where it came from and what's happened to it since? Because if we don't know who's edited it, then it lacks integrity. It might happen to be correct, but it lacks integrity. Relevance is really important, and I've got a bit of a story for this one, which is what this is meant to remind me of. Let's see what it says on the slides. It says that the information directly addresses the specific purpose, context, and problem at hand, ensuring that the collected information is meaningful and applicable to the intended objective. I used to work at a school that had this very swanky new building, and it was all state of the art at the time, and it had a box that connected over the internet to a weather server, and it would get the conditions for how hot it was and how strong the wind was and stuff, and so you didn't have to open the windows or anything. The louver windows would open themselves, and they would open themselves on the right side of the building to catch the breeze, and it could control how strong the fans were and all of this stuff. So this data hadn't been tampered with. It was very accurate, but it failed the relevance test because it had accidentally been set to be in Belgium rather than Geelong. So relevance is, we've got a data set, it's just not actually the right data set we should have for addressing this problem. Now, that's a very dramatic example. There are other less dramatic examples of relevance where we're using data which seems like an okay fit, but it isn't really addressing what it is that we want to know about. Now, reliability in this context means, is it the same every time? I don't mean that I measure the temperature and that says that it's 21 degrees out there all the time, but is it consistently measuring the same temperature as the same temperature? Now, that seems really obvious, but In science and the social sciences, we need to know that if we do A and B, then C is highly likely to happen, or it's definitely going to happen, not just that it happens sometimes and it doesn't happen sometimes. In psychology, which is what my undergraduate degree is in, we talk about reliability of tests. So if you give me a test and I get 85 one week and 65 the next week and 100 the next week, without me really being any different, then that test has a low measure of reliability because there's a lot down to just when I take the test. So imagine when we're looking at this image here that we want to know the dynamics of this swing, but we're putting a different person on the swing, different people are pushing it. We're going to have a low reliability because we're not going to be getting consistent results from it. So that's what reliability means. It doesn't necessarily mean you can rely on it. It's a measure of the sort of stability of what you're measuring. And it's about being able to having a predictable performance and random variations. And reliability, for some reason, I have twice in this slide pack. Okay, let's finish up with some true or false questions. Data accuracy refers only to whether numerical values are correct and does not apply to text-based information. Well, that's false. Bias in data collection occurs when the sampling method or data gathering process systematically favours certain outcomes over others. Yeah, that's literally what bias means. In fact, in lawn bowls, we talk about the ball having a bias, and it doesn't mean that the ball is sneaky or underhanded or dishonest. It just means that it consistently rolls off to one side because of the way that it's weighted, if that helps you remember bias. Data integrity means that information remains complete, consistent and unaltered by unauthorised parties through its storage and transmission. Yep, that is in fact exactly what data integrity means. Integrity means we know who made it, we know who's edited it. Information is considered relevant if it is accurate, regardless of whether it addresses the specific question or problem being investigated. Well, that's false. That's not what relevant means. Relevant isn't a measure of accuracy. It's a measure of whether it's targeted or appropriate for our field of inquiry. Confirmation bias in data analysis occurs when analysts unconsciously select or interpret data in ways that support their pre-existing beliefs. Yeah, that's 100% what that means. And by the way, nobody's setting out to do confirmation bias. Confirmation bias is, by definition, something we do without realising that we're doing it. Nobody's setting out to do it, but this is where it's important to rigorously look at it and socialise it with other people, and so that they can say, oh, hang on, are we really capturing the truth of it here? Relevance and accuracy are interchangeable terms when evaluating the quality of information for a particular purpose. Well, that's false, they're not. Relevance, is it suitable for this situation? Accuracy, are these the correct values? Okay, I think we're down to the last page of questions. Data reliability refers to the consistency and dependability of data when measured or collected repeatedly under similar circumstances. Yeah, that's literally what reliability means. It means it's consistent under the same circumstances. Selection bias can be eliminated entirely by using only digital data collection methods instead of manual methods. No, you can absolutely have selection bias. In fact, you probably often do. If I'm only selecting people who, if I survey my class and that's the people who turned up on the day, and I haven't got the people who weren't there today, and perhaps they weren't there because they have a slightly different view. So no, that one is false. So that is the end of that presentation. I hope that was useful to you, and I will see you another time.